Good day, everyone. I am Alexia de la Cruz, and today I will discuss about two topics. First is the spread spectrum techniques and its types. Second is the multiple access techniques and its types. Now, let's go first with the spread spectrum. Spread spectrum refers to a system originally developed for military applications to provide secure communication by spreading the signal over a large frequency band. This figure represents a narrow-band signal in the frequency domain. These narrow-band signals are easily jammed by any other signal in the same band. Likewise, the signal can also be intercepted since the frequency band is fixed and narrow, or easy to detect. The idea behind spread spectrum is to use more bandwidth than the original message while maintaining the same signal power. The spread spectrum signal does not have a clearly distinguishable peak in the spectrum. This makes the signal more difficult to distinguish from noise and therefore more difficult to jam or intercept. A collective class of signaling techniques are employed before transmitting a signal to provide a secure communication, also known as the spread spectrum modulation. The main advantage of spread spectrum communication technique is to prevent interference whether it is intentional or unintentional. The signal modulated with these techniques are hard to interfere and cannot be jammed. An intruder with no official access is never allowed to crack them. Hence, these techniques are used for military purposes. The spread spectrum signals transmit at low power density and has a wide spread of signals. There are four techniques of spread spectrum, namely direct sequence spread spectrum or DSSS, frequency hopping spread spectrum or FHSS, chirp spread spectrum or CSSS, and time hopping spread spectrum or THSS. First, let's go with the direct sequence spread spectrum. The direct sequence spread spectrum is a form of transmission that looks very similar to white noise over the bandwidth of the transmission. However, once received and processed with the correct descrambling codes, it is possible to extract the required data. When transmitting a DSSS spectrum signal, the required data signal is multiplied with that is known as a higher or spreading or chip code data stream. The resulting data has a higher data rate than the data itself. Often, the data is multiple using the XOR or the exclusive OR function. Next, let's go with the frequency hopping spread spectrum or the FHSS. The frequency hopping spread spectrum is the transmission that is repeated switching of frequencies during radio transmission to reduce interference and avoid interception. It is useful to counter eavesdropping or to obstruct jamming of telecommunications. And it can minimize the effects of unintentional interference. The idea beyond FHSS was discovered and rediscovered several times in the 20th century. The concept was initially mentioned in print in 1908 by German Johannes Zenneck, but credit for FHSS really belongs to actress Hedy Lamarr, who worked with the composer George Athale to bring the technology into existence during World War II. Now let's proceed with the chirp spread spectrum or the CSSS. A chirp is a sinusoidal signal whose frequency increases or decreases over time, often with a polynomial expression for the relationship between time and frequency. In digital communications, chirp spread spectrum is a spread spectrum technique that uses wideband linear frequency, modulated chirp pulses to encode information. Then last, let's proceed with the time-hopping spread spectrum. Time hopping is a communication signal technique which can be used to achieve anti-jamming or AJ or low probability of intercept or LPI. It can also refer to pulse position modulation, which in its simplest form employs the 2 raised to k discrete pulses, referring to the unique position of the pulse within the transmission window to transmit k bits per pulse. Now, let's proceed to the second topic, which is the multiple access techniques. Sometimes, a satellite service is present at a particular location on the Earth station, and sometimes it is not present. That means a satellite may have different service stations of its own located at different places on the Earth. They send carrier signal for the satellite. In this situation, we do multiple access to enable satellite to take or give signals from different stations at the time without any interference between them. The following are the three types of multiple access techniques. First is the FDMA or the frequency division multiple access. Second is the TDMA or the time division multiple access. Last is the CDMA or the code division multiple access. First, let's talk about the FDMA or the frequency division multiple access. FDMA is the wireless implementation of FDM used in satellite transmission and earlier AMPS analog cellular networks. FDMA divides the bandwidth into separate channels, one for each user. In this type of multiple access, we assign each signal a different type of frequency band range. So, any two signals should not have the same type of frequency range. Hence, there won't be any interference between them, even if we send those signals in one channel. One perfect example of this type of access is our radio channels. We can see that each station has been a different frequency band in order to operate. Second is the TDMA or the time division multiple access. TDMA is a channel access method for shared medium networks. It allows several users to share same frequency channel by dividing the signal into different time slots. The users transmit in rapid succession, one after another, each using its own time slot. This allows multiple stations to share the same transmission medium, for example, radio frequency channel, while using only a part of its channel capacity. As the name suggests, TDMA is a time-based access. Here, we give a certain time frame to each channel. Within that time frame, the channel can access the entire spectrum bandwidth. Each station got a fixed length or slot. The slots which are unused will remain in idle stage. Last is the CDMA or the code division multiple access. CDMA uses a spread spectrum technology to transmit data. This technology permits several phones to send and receive through a single channel. Each part of these separate conversations is labeled with a specific digital code. In CDMA technique, a unique code has been assigned to each channel to distinguish from each other. A perfect example of this type of multiple access is our cellular system. We can see that no two persons' mobile number match with each single, although they are the same X or Y mobile service providing companies, customer using the same bandwidth. In CDMA process, we do a decoding of inner product of encoded signals and shipping sequence. So here are my references from this video. First is the NI or Engineer Ambitiously. Second is the Science Direct. Third is the Electronics Note. And last is the tutorial point. Thank you for listening.